I would like to introduce Jesus to moderate the next session, the third competition, which is the self-supervised learning in the autonomous industry. Jesus, welcome back.
Thanks, Thomas. Hello, and welcome back to the final competition, self-supervised learning in the autonomous industry. In this ever-evolving landscape of AI, we continuously seek for new methods to enhance the capabilities of our machine learning models. Traditional supervised learning, where human label data is used to train AI system, has been very successful. We also saw in the previous section that I moderated how synthetic data is also playing a crucial role in this too. However, traditional supervised learning has its limitations, particularly in scenarios where obtaining label data is expensive, time-consuming, or impractical. This is where self-supervised learning takes center stage. Self-supervised learning represents a paradigm shift in enabling AI systems to learn directly from unlabeled data, thereby reducing the dependency on large quantities of annotated examples. It is a groundbreaking approach that has the potential to democratize AI development and unlock its full potential. So let's discover who of our finalists are today here and how they can apply self-supervised learning to their products. First, let's extend a warm welcome to a remarkable individual and an AI enthusiast, the 16-year-old Zainab Elumi, who joins us from the Warriors teams with Insights Road project. Insights Road offers a unique self-supervised learning model that places a strong focus on detecting unusual behaviors in other vehicles and, most importantly, road surface conditions. It also aids in identifying pedestrians who may not be following traffic rules and road obstacles, all utilizing unlabeled data. This innovative project not only ensures safer and eco-friendly travel, even in the harshest weather conditions, but also shares the collected road data for state improvements. Please join us in welcoming Zainab and the Warriors team.
Hello, everyone, and welcome. Do you see my screen?
Yes.
Okay, so today I'm going to present you my project on self-supervised learning in the autonomous industry. As we can notice nowadays, the autonomous vehicles, once the domain of science fiction, are no longer a futuristic vision, but a reality that is transforming our relationship with mobility today, as they can reduce human errors and increase fuel efficiency. Now I'm going to tell you my little story with self-driving cars. One day, while watching a documentary on these sort of cars, I noticed that they never spoke of projects in Africa or some Asian countries like India. Living in Tunisia, a North African country, I felt that it wasn't fair toward us, so I directly rushed to my father to ask him about the reason behind it. He told me to go out with him and pointed to the road. Then he said, "You see the number of potholes, daughter? The road is in a pitiful state and the difficult weather conditions can make it more dangerous for the vehicle. This is the answer to your question." That was the moment I realized I had to do something, and this hackathon was the perfect opportunity to work on my project, Insight Road. Insight Road is a solution to all these problems. It offers a unique self-supervised learning model that focuses on detecting unusual behavior of other vehicles and, most importantly, road surface conditions. It also helps detect pedestrians who are not following traffic rules and road obstacles. In addition, the proposal represents a significant step forward for humanity due to its environmentally friendly nature, but it also gathers and detects road anomalies to build a useful dataset. The system is a controlling model that could send warnings and alerts to the road control community in order to supervise any dangerous road anomalies that cause many issues such as accidents. But why SSL with autonomous cars? No labeling dataset is needed. It's less time-consuming, and it's a certainly innovative approach. However, it is essential to note that self-supervised learning is still an emerging field, and further research is needed to fully optimize and integrate these algorithms into self-driving cars and transportation systems. That is is one of the many reasons my project is an innovative and a revolutionary one, as it being one of the first one using SSL to solve the autonomous cars problems. The dataset collected from different sources from the internet and used in our Python code can either detect the unusual behavior of other vehicles on the road, pedestrians, road obstacles and debris, or even road surface conditions. I managed to collect public data that has over 12K of unlabeled images. Here is an example of pothole dataset that has 645 training sets and 29 testing sets. But how does it actually work? It will be a binary classification and a binary decision. Each frame from the video captured from the camera of the car will be an input to all the three classifiers you see here that have the same model based on an SSL approach. If it is a pothole, a debris, or a pedestrian, then yes, it is an anomaly. If not, it's not. We can also have 2 or even 3 anomalies combinations. We're moving now to the SSL approach. We applied the jigsaw puzzle method as our baseline. The features learned during the practice task using a large dataset are fine-tuned for our downstream classification, including pothole classification. To prove that our model is efficient, we will show you the results. As the left graph shows, the training and validation loss decrease during the training process. This indicates that our classifier is learning and improving its predictions. Plus, the confusion matrix shows that the model is about 92% accurate in its prediction overall. Finally, I wanted to present myself. I'm Zainab Bloomy from Warriors team, and yes, as you can see, I'm just 16 years old. It's been years now that I study ML in Python with my personal coach that I really want to sing, and I found that it was time to practice my knowledge by joining competitions. My childhood dream was and still is to obtain a scholarship in order to study at Harvard or MIT or Stanford. So here are some additional materials about the dataset, the GitHub link, the link of the paper, and my previous presentation. With Insight Road, discover, detect, and drive safely. Thank you for your attention, everyone.
Thank you very much, Zainab, for the exciting and inspiring presentation. Well done. Next in line for this category, we have Team Skynet, introducing autonomous fire detection drones designed to address critical challenges in emergency response. By harnessing cutting-edge technology, their aim is to eliminate human safety risks, manage data overload, and enhance accessibility. With this solution, they seek to revolutionize the way we detect and respond to fires, making our communities safer and more resilient. The team is composed by Adigun Idowu Michael, Daniel Eniayehu, Olaboye Victor, Kanishka Srivastava. Welcome on stage.
So once again, I am Adigun Michael, and my team and I are privileged to admit to this finalist. And it's a great opportunity for us by worldwide AI to raise this opportunity. I'll begin with the problem I'm trying to solve. Yeah, so we're trying to solve the problem of immersive series in data. In the world today, different actions lead to fire incidents, and this fire incident pose significant challenge in human safety or poverty preservation and natural resource preservation. And according to the National Fire Protection Association, in 2021, about 1.4 million fire incidents were recorded in the United States, leading to about 3,800 deaths and about 14,700 casualties. Humans will act as first responders to fire scenes are usually faced with danger, which could jeopardize their safety. And others, human safety is also of data overload. In the world today, where we have a large amount of data coming from different sources, like sensors and cameras, this data influx could pose significant challenge on the firefighting team, processing and interpreting data in real time in order to make informed decisions. And we can see in my next slide recent problems, especially wildfire incidents that occurred recently on the Hawaii Islands of Maui, leading to about 10,000 evacuations. part of the challenge that was faced in this case was limitation to emergency response. How I wish that there were solutions to this already implemented, and we wouldn't have had so much loss of lives and so much loss of properties and so much Also, we also have a recent case in South Africa when the fire incident killed about 5 soldiers in the leads of 76,000, leads of 76 deaths. So, in view of this, we decided to come up with autonomous fire detection. Admin is able to use artificial intelligence to analyze fire scenes, detect and analyze the situation, thereby providing insights and actions to keep the fire department. Just briefly, I'm going to show you a demo of our video in action. In this video, we're using Unreal Engine and SU for the ground simulation, whereby for the model we're using results. Okay. And for the model, we're using self-supervised machine learning technique like colorization. So if you can still hear me, you can see the object detection happening at the top corner of the screen. So yeah, this is just a short demo showing how our drone is detecting objects in action. And we use Unreal Engine and testing for the simulation of your model using soft-based machine learning technique like colorization and mutation in order to then use features of implementing downstream tasks for this detection and classification. So our target market includes fire department, government agencies, and tech companies. Our drones can help the fire department help improve situational awareness, and for government agency help in enhancing resource allocation, and for tech companies, our products are broken up into software and the which software can be implemented. Other soft hardware like companies that are already existing autonomous systems or vehicles. And our pricing model includes pay-as-you-go subscription and depending on the option that best suits our customer. And we have other industries and companies already into that provide unmanned area services to unmanned area systems to companies. What makes us stand out is our ability to be able to provide very specific information in fire scenes and also provide spatial resolution, which is able to help detect smaller fires like images from satellite. As you can see, we're futuristic and therefore we are not stopping there. And currently, at the current moment, we have object detection and our future implementation includes things like autonomous navigation, data sharing, and real-time monitoring. And this is the high-level overview of our milestone, showing that we are working on this and we plan to get it out. Thank you.
Thank you, Idowil. Just in time. Thank you for the presentation and the inspiring message.